Welcome back, everyone. I've got a question about forces on inclined planes, everyone's favorite topic, and I think if you're someone who struggles with this, or maybe don't know how to attack some of the more complex forces on inclined planes questions, I want to show a different method that I've been preferring lately, which I think actually simplifies a lot of this stuff. This is a harder question maybe because it's not something in equilibrium, so we actually have an acceleration we're going to calculate. We use a little bit of Newton's law to do that as well, or Newton's second law specifically. So I think it's good. I think this is a good question. Obviously there's more complicated stuff that can happen with the diagram side of things. We can make the picture very complex. We're going to keep the picture pretty straightforward just to demonstrate a different way to solve them. I've tried this with a lot of hard, challenging inclined plane questions, and I think this is good. I think if you struggle with this, you'll prefer this method. It makes everything a little bit easier to process. So I have a 10 kilogram object. It's on an inclined plane at 60 degrees to the horizontal, so it's incredibly steep. There's friction of 10 newtons. Find the acceleration down the plane and the normal force. So let's start by drawing the sort of classic diagram. That's going to be, there's my inclined plane. There's sort of like the bottom part. This angle here is going to be at 60 degrees. I have some kind of object. Let's do that in purple. It has a weight force going straight down, something like that. This is going to be, if I do it in newtons, times my weight by 9.8, I get 98 newtons. I also have a friction force. Friction force kind of goes against the motion, so that goes up the plane. That's going to be at 10 newtons. And I have a normal force, sometimes called the reaction force. That is going to be perpendicular to the plane, something like that. So that's my force diagram, okay? Now, I'm going to redraw this. The way I'm going to redraw this is I'm going to put this on a normal Cartesian plane. I'm going to make the plane itself the x-axis. And I think this simplifies my picture. This is kind of how I've been preferring to teach this topic lately. So let's draw my Cartesian plane. Okay, I'm going to draw myself a Cartesian plane. I'm now going to put my forces in. Let's start with my normal force. That is going to be, as I kind of wobble my screen, my normal force is going to be directly vertical like so. I have a friction force that goes out this way here. That's going to be at about 10 newtons. This here is my unknown force N. And now I have my weight force. We'll do that in orange as well. My weight force is going to come out something like this. So I need to find the angle my weight force makes with the horizontal. In other words, I'm trying to find this angle here. Make this line a little bit better. I want to find this angle here. So to find my angle my weight force makes with the plane, I want to create my own Z angle. If I do that, I can kind of draw a parallel line here. We can see that these two lines are parallel. So I wind up with alternative angles. If this part here is 60, that means this part here is also going to be 60 degrees. The whole thing's going vertically down. So my little orange angle, this angle here, is going to be at 30 degrees to the horizontal. So I have 98 newtons here. My angle to the plane is 30 degrees. And I've now changed my picture. I've simplified it, at least for me, I think it looks more simplified. And I can just break my vectors, my forces up into components. So let's scroll down. I'm going to start with my I component. Okay, that's going to be my horizontal components. If I take the sum of my forces in the I direction, this is the sum of my horizontal forces, I wind up with 10 newtons. That's my friction force. That's positive. It's going towards my right. Minus, because it's in quadrant 3, so cosine is negative in quadrant 3, and the I component of my orange force, this force here, if I kind of take this force and I put it into component form, I wind up with 98 cosine 30 degrees, or negative 98 cosine 30 degrees I, minus 98 sine of 30 in the J direction. So that's my force in component form. The I component of that is negative 98 cosine of 30 degrees. So I've got the sum of my forces in the I direction using my exact value triangle. Therefore, I get 10 minus 49 root 3. That is all of my forces in the I direction. So if I want to find the acceleration in the I direction, I'm going to use Newton's second law. The sum of forces in the I direction is equal to the mass times the acceleration in the horizontal or the I direction. So I get 10 minus 49 root 3 is equal to 10a in the I direction. Divide both sides by 10 and I wind up with the acceleration, or my horizontal acceleration, is equal to, well, 10 divided by 10 gives 1, minus 49 divided by 10, which gives 4.9 root 3. I've now found my acceleration. That is part 1 done. Now let's look at the second part, finding my normal force. That is my pink force here. So to find my normal, I now want to find my J components, or my vertical components. So my J components, again, are going to be the sum of forces in the J direction, equal to, let's put my normal force in pink, minus the normal force in the J direction from my weight. That is 98 sine of 30. Okay, so it's a little bit over to the side here. Let me zoom in a bit to make that part a little bit bigger. So I know that in the J direction, my normal force balances out the weight force of the box, and it's stationary, or it's in equilibrium in the vertical component. It's only moving along the plane. So my force is perpendicular to the plane, sum to give 0, which means I have 0 is equal to n minus, well, 98 divided by 2. Sine 30 is a half, so 98 divided by 2 gives 49. So therefore my normal force equals 49 newtons. And I've now solved my question. So by making my diagram like this, I simplify it, I make it a bit easier to interpret, and I also make my forces just as easy to calculate. I think it's better. Doing this more now, like I said, I've tried this with really hard questions. I think this is a superior method. As things get more complex, I think this is pretty good. Curious to hear what you think. If you're struggling with questions that relate to forces on inclined planes, we've all been there at some point in our learning journey. Feel free to let me know in the comments so I can make more stuff like this. Otherwise, hope you guys have a good day, and I'll see you guys in the next video.